let's be nice to our customers. Let's have a deal which says if you buy 9 drinks, the 10th one is free. So if you buy 9 energy drinks, the 10th one's going to be free. So a question is, how could we modify our algorithm to take advantage of that feature? And there's a slew of answers that are possible here. So think about this, talk amongst yourselves if you like, and let's start kicking around some ideas how we could change this. If you buy 9 drinks, the 10th one is free. Any thoughts or ideas?
Another if statement confirming if there's more than 9 drinks.
Mm-hmm.
And if there is, add 1 to the current value.
Okay, so if there's more than 9 drinks, and the most they can get is 10, right? So if there's more than 9 drinks, we want to somehow have the cost be only the cost of 9 drinks instead of 10. So yeah, we could add some sort of if statement. So I'm just going to get really sloppy here, and I'm going to say, okay, we're going to do one extra thing here. Well, I guess I can just continue here. And let's say, is the number of drinks equal to 10? Because if it's more than 9, it's got to be 10, because if it was more than 10, it would have already said that's too many and exited. So is the number of drinks equal to 10?
Well, what if somebody put down 9.5?
We're going to assume that there's no fractional drinks. Okay, but we'll talk about how to deal with that too. Okay, that's really good thinking though, because when you're developing these programs and you start testing them to turn in, a really big part of it is sort of the final check to make sure your program works. And that comes down to being able to think of things exactly like that, right? And if you always test this thing with whole numbers, right, to give it to your teacher, probably one of their tests is, I want 9.5 drinks. And if your program blows up when that happens, right, it's better if you discover that than your teacher. So being able to think of edge cases, right, the weird user cases that are outside the norm is a huge part of successful programming. But you don't have to do that for this. Okay, so if the number of drinks is 10, well, if not, then, you know, we're just going to go right on down to where we were and do what we did before. But what could we do if the number of drinks is 10? Yeah, subtract 1 from number of drinks. And then go back to where we were. So now I'm getting what we call spaghetti code. So if you had negative drinks or too many drinks, you're going to come down here to your end. But if you have the number of drinks that's equal to 10, we'll just set the number of drinks to 9, and we'll continue to calculate the cost, tell you how much you owe. And it'll be the amount you owe for 9 drinks, even though you're getting 10.
Would you add a print statement, just tell them, just let the user know why you purchased 9 drinks?
Sure.
Just an idea.
So let's just say tell user about discount. So yeah, we'll throw in a print statement and say, congratulations, your 10th drink is free. Well, let's add that to our code. The user asks for 10 drinks, only charge them for 9. All right. Here is something you definitely want to pay attention to, because at some point during the quarter, this will come back and haunt you. And this can cost you like the rest of the night if it's been a long day. When you're doing a comparison statement as part of an if, when you're trying to ask a yes/no question like is the number of drinks equal to 10, it's got to be 2 equal signs. That's just the way C is. Okay, so if number of drinks is equal to 10, so let's give them a discount. Only charge for 9 drinks. So I could do num of drinks equals num of drinks minus 1. Or I could just say num of drinks equals 9. But num of drinks minus 1 somehow feels better. And we'll give them a message, tell them their 10th drink is free. And that's the end of the discount calculation. And then we go on, we calculate the cost of drinks.
In that first time you read that statement, how does it separate the comment from the number of drinks equals number of drinks minus 1? Like, wouldn't it like...
This one?
Wouldn't it just like fit together since there's like no separation? Or is the space in that?
So you mean this one?
No, the one before.
The one before.
On top of that one. As a comment, and then after 9 drinks, it just goes straight to number of drinks.
Comments are only per line.
Yeah, so if I say / to start a comment, it only goes till the end of the line.
Okay.
And then when you get to the next line, that's not a comment anymore. Right, now if I said /*, then I'd have to have a * / somewhere to end it. But yeah, / is a shortcut way of writing a comment. All right, so how many drinks would we like? -5, that's still weird. 100, that's still too many drinks. 5, that's still $7.50 plus some tax. 10 drinks tells us your 10th drink is free, and instead of being $15, it's $13.50. And the tax is correctly calculated on that $13.50, not on the original $15. And the grand total is the sum of those two. And that all seems to work great. And why didn't we have to worry about adjusting the tax and so on? Because the way that we implemented this discount was we just changed the number of drinks to be 9.
Would this be a place that we would use in unary operation or no?
Would where be?
Because it is number of drinks equals number of drinks minus 1. Or no?
So we could do this. Like that?
Yeah. Okay.
Right, that's perfectly legal.
We'll try you to write it.
And this would also work.
Okay.
And this would also work. So minus before or minus after says subtract 1. Num of drinks minus equals 1 means num of drinks equals num of drinks minus 1. It's just another shorthand. Let's see what happens if we forget to say equal equal, and we just say if num drinks equals 10. Compiles perfectly fine. Not even a warning. How many drinks would you like? 10. 10th drink is free. Hey, that worked great. How many drinks would you like? 5. Hey, your 10th drink is free. Give me $13.50. That's a little weird. -1, that still works. 100, that still works. I'd like 1 drink. Hey, your 10th drink's free. Give me $13.50. So something is broken, right? Well, we know where it is because we're the ones who broke it. But suppose we don't. Well, we know this part seems to be working. If the number of drinks is negative, it's catching that. If the number of drinks is bigger than 10, it's catching that. And this seems to be calculating the correct amount for 9 drinks, and the print statements are fine. Something's going on in here. This is one of the hardest errors to find in C because it doesn't give you a warning when you compile. And if you've been staring at this for hours, your brain's just going to go right past it. Right? It's like typing the same word twice in the middle of a 5,000-word essay in your proofreading. You're not going to see it. You're going to see what you think you wrote. And I don't have any tricks for how to catch this. But after about the 5th time that you've lost a few hours of your life looking for this bug, you'll start to think immediately, oh, maybe I've got a single equal, right? And you'll somehow develop this like 6th sense about it, and eventually it gets easier to catch. What's actually happening here is I'm assigning number of drinks to be equal to 10. That's what a single equal sign means, right? I'm doing it inside an if statement, but C allows that. It's a feature or a bug, depending on your perspective. So when I get to this if statement, number of drinks is set equal to 10. And then it says if number of drinks, and for other reasons that if statement turns out to be true. So then it sets number of drinks to 9, says congratulations, and rings me up for 9 drinks. So that's just something that can pop up sometimes.
So because we want the if to go after, if it's not 10, we don't have a return 0 here?
Because if the number of drinks is 10, so like this.
Yeah, that would end the program.
Yeah, so if we put a return 0 after that, and we say how many drinks would we like? 10, congratulations, your 10th drink is free, and then the return said exit the program. And we didn't get to see what the totals and the tax were. So if you don't say return when you finish an if, it just continues with the next statements, right? And it's basically, in this case, after we decrement the number of drinks, we want to go back and continue the same way that we would have if the number of drinks was not equal to 10. So we're coming back to this branch and just flowing through. So other questions so far?
If we want to save, so say you're doing that, the 10th one is free.
Mm-hmm.
You just want to save your program, make a copy of it, like a save as, I guess.
Mm-hmm.
Title it something different. How do you do that in VI?
In VI, I can say :w p2.backup or whatever I want to call it.
Okay.
And it writes a new file called p2.backup.
Okay.
Okay, but I'm still editing p2.c.
Oh,
So if I make some changes and I write, it's writing p2.c.
Okay.
I'm not switching files, I'm just making a temporary copy of it.
Okay, you'd have to get back out and then back in.
Yeah.
In that program, okay.
And the other option is if you go back to the command line, you can copy p2.c, another backup. And that also makes a copy. So now I got a few copies.
All right.
Yeah. All right, so they want 4.5 drinks. And it charges them for 4. Because scanf doesn't actually read 4.5. All right, so let's how many drinks would you like? Number of drinks. So I'm adding what's called a debug statement. This is just something that I'm putting in to help me figure out what's going on. So I'm going to put a comment here which says debug. And this is just a reminder to me that the lines that I'm about to write are not actually part of the program that I want to actually deliver to the user in the end, right? This is just something I'm doing to see what's going on. Let's just print out what the value of number of drinks is. And if I run that and I ask for 4.5 drinks, my debug statement here tells me number of drinks is actually 4. It's not seeing my 0.5 because I'm reading in an integer. If I want to actually see that they put in 4.5 and say that's not a real number, that's not a real integer, right? I need to be able to actually input 4.5. So what would I have to change in here in order for a number of drinks to be able to be something like 4.5 so that I could yell at the user?
Change it from an integer to a double.
Change it from an integer to a double. So I'll just make number of drinks double. And if I'm not careful, and I try to compile, I'm going to start getting errors. And if I ignore that and I just go ahead and I run this, I'm going to get weird stuff. Right? The type of a variable is really, really important. And it probably affects a lot of other things in your code. So I'm going to search in VI with a slash for number of drinks. And this is where it's better to use a variable name like number of drinks than I. Because I pops up all over the place. It's in comments, it's in other variables. Number of drinks is really only going to pop up when I'm talking about that variable. So a number of drinks pops up there first. That's the one that I just changed. Do you remember how to find the next occurrence of something in VI? The shortcut? N for next. So next is down here. There's my scanf. Okay, what's going on here that I have to change?
It's asking for an integer now.
It's asking for an integer. That's what %i is. So what should this be instead? LF for a double. Okay, so now I'm scanning for number of drinks as a double. And now I'm going to print out number of drinks. Does this have to change?
Yep.
Same thing, %d or %i is for an integer. Let's make that a %f also. There's number of drinks again. Is it less than or equal to 0? Does that work fine? That'll work, that'll work, that'll work. That'll work. My comments are fine. I can multiply a double by a double, and I'm back to the top. So I've probably captured all the changes I needed to make. So number of drinks 4.5, and it tells me number of drinks was 4.5. Let me use a slightly more revealing. Let's ask for 0.01. Yep. So now it's actually giving me as if I had a fractional number of drinks. Okay, well I'd like to yell at the user if they put in a fraction and say please put in a whole number. So is the number of drinks negative? If it is, print goodbye. Is the number of drinks bigger than 10? That's too many. Can we throw a check right here and say is the number of drinks a whole number? That's probably a reasonable place. So is number of drinks a whole number? And if it is, we'll go on, we'll see if there's a discount and so on. But if not, we'll print something and we'll go down to the end of the code. We'll do our return. All right, asking for too many drinks. No. Okay. Make sure the user asked for a whole number of drinks. All right, this is a little tricky. All of this is a little tricky. This is a little more tricky. We have a double, and we'd like to know, is this double an integer? So suppose x is a double. Okay, there's a special thing we can do in C. If we write the name of a variable, but in parentheses in front of it, we put the word int, it will change x. It will take the value of x and it'll pretend that x is an integer. And this will be equal to the value that x would have if it was an integer. In other words, it will round it or truncate it to a whole number. So if we want to know if x was actually a whole number, we could say, is x equal to integer x? And if x is 7, integer x is also 7, they're going to be the same. If x is 7.2, integer x will be 7, they'll be different. Okay, so this is arguably the weirdest thing we've done so far. Here's the second weirdest thing. We want to say if number of drinks is not equal to the integer number. Right, so if the number of drinks is not a whole number, we're going to rewrite this as follows. Is the number of drinks not equal to the integer number of drinks? And if it's not equal, we'll go ahead and we'll print out a message. Otherwise, we'll just continue. Okay, so two equal signs are how we check to see if two things are equal. If we want to know if it's not equal, we use an exclamation mark followed by an equal sign. So equal equal means equal, exclamation mark equal means not equal. In general in C, an exclamation mark means not. You'll see it pop up in different cases, but this is the sort of classic case, not equal. Okay, so if number of drinks is not equal to integer number of drinks, bless you. User didn't enter a whole number. Let's print a nice message for them. We'll say %f is not a whole number. and we'll just remind them what number they put in. And we'll return. Alright, -5 is still weird. I've got my debug statement in there. Let me get rid of that. So I can search for debug and find my debug code. And I could delete this. I'm just going to comment it out, because if my code doesn't work, I might want to put it back in at some point. Usually I would just delete it, but sometimes you write 10, 15, 20 lines of debug, and when you don't need it, you don't really want to like have to type it in again later. So you could just put a /*/ around the whole block of code, make it one big comment, and then maybe I'd remove it before I actually turned it in. Okay, how many drinks? -5, that's still weird. 100, that's still too many. 5, that still works. 9, that still gets me my, no, that does not get me my discount. But 10 gets me my discount. Alright, and then 4.5. 4.5 is not a whole number, and it exits. Yeah.
So is there only, I mean, if doubles work in almost every scenario that integers have problems, I mean, should we just always use doubles?
Doubles take more memory, and they're somewhat slower than integers.
Okay.
And they're not always exact. Although for integer values, they should be pretty exact. But I think you can get up to 2 billion with integers, and it'll be exactly, you know, incremented by 1 each time. Doubles, before you get to 2 billion, you'll start getting into rounding errors. They just don't have as much precision in that sense. But yeah, a lot of times people just sort of live with doubles. There's cases where integers really make sense, though. And you know, arguably number of drinks should always be an integer. And there's other ways we could catch the fact that they put in 4.5 and they should have put in an integer. So it's kind of a forced example. And what we're going to do next, which is looping, we'll want to use integers because it just sort of makes the most sense. But yeah, it's a fair observation. All right, is this making some sense? Right? So the details aren't critical here. The idea here is we can just keep going and going, right? And we started with you know, a very simple program on Tuesday, and we started adding to it until we got to where we could have a number of drinks, and we could add in some tax and stuff like that. And that gave us a pretty good program. It was a good chunk of program too. And now we've just been adding more and more behavior to it, right? And we could keep going. We could do all kinds of things. Every 4 drinks, you could get a 5th one free, right? And so we could add some extra discounts. We could handle this discount differently, right? We could do all kinds of things. There's other ways to give them a 10th drink for free than just changing the number of drinks to 9. We could change the cost of a drink to be 10% less, right? There's all kinds of things we could do. But it's really up to you, the programmer, what you want to do and how you're going to do it. And the sort of art of programming is getting to a point where you can say, okay, now I want to do this, and you may not be, you know, explicitly drawing a flowchart, but you're certainly thinking something like that in your head. What's the algorithm? What are the steps that I want to do? And then going through translating that into some code. And you know, we're up to a 79-line program now. That's pretty good. Alright, so that's a good chunk of code. So what does the term debug mean? I've tossed it around and talked about debugging code.
Something's not working, you're trying to isolate the problem.
Something's not working, you're trying to isolate the problem. So Grace Hopper was an admiral in the Navy. She was one of the first programmers on the early machines, the early programmable machines, and she taught, you know, generations of programmers how to do their thing. And she was working on an old machine. It was a relay-based computer. So relays are these little mechanical switches. There's a piece of metal inside, and there's an electromagnet. And when you run current through this coil of wire, it becomes magnetic, and it pulls a piece of metal towards it. And when that piece of metal moves, it moves a switch to either open or close. And when you stop running current through that coil, there's a spring that pulls that piece of metal back into its original position. So a relay is like a mechanical transistor. It's a way you can use current to start or stop the flow of current somewhere else in a circuit. And you can put relays together the same way we put transistors together, and you can build logic gates, engineering 250, things that do logical operations, and you can put those together and build computers. And early computers were often relay-based. And these were, you know, the room-sized computers, because relays are physically large, and they were fairly noisy because they click every time they move, and they're also prone to failure, right? They can mechanically fail because you have moving parts. They're also fairly slow because you turn on this magnet, you have to fight this spring for this piece of metal to make contact, and when you take away the current, the spring has to pull this piece of metal back. It's relatively slow compared to electron flow. So Grace Hopper was working on a trigonometry set of code for doing sines and cosines and things like that, and the answers were coming out wrong. And she went back into the computer. Okay, you could walk around inside a computer, and she started, you know, looking at what the code was doing and going through the circuitry, trying to find out what the problem was, and she found this. So she found a moth inside one of these relays. And these relays, they have little plastic cases on top. But somehow this moth had gotten inside, and its body was wedged between where this piece of metal should make contact with this other point. And so when the current ran through and the switch tried to move, it wasn't making contact. It was a failed transistor, basically. So relay 70 panel F, moth and relay, right? This was her lab book. And so she took the moth, she actually taped it into her lab book. She said, first actual case of a bug being found, right? So debugging was apparent, or bugs were at least the words before this happened, but that was a genuine bug. So debugging is the process of removing bugs from your code, hopefully not from the inside of your computer. But it's finding what's wrong and getting rid of those things. All right, let's talk about loops. And this isn't even stuff that I was just supposed to like introduce this to you. So you're going to see all this stuff again and again. Okay, this is just kind of a first pass over if statements and loops. So don't feel like you have to nail it down right now. This is just sort of a first time to see it if you haven't seen it before. All right, so here's what might be called a hello world. And it just prints out hello. All right, there's a thing called a for statement. So for statements say FOR, that's a keyword, and then there's three things that go inside the parentheses, and then curly brackets, and a bunch of stuff inside here, whatever you want. Okay, here's a typical for statement. For, so let's suppose that somewhere I've said that I is an integer. Okay, I can say for, and the first thing I'm going to say is I equals 0. That's called an initialization condition. That's saying I want I to be equal to 0. The next thing is a true-false statement, a yes-no question. And I'm going to say I is less than 10. So this is an initialization. This is a statement that if it is true, the loop is going to continue looping. If I is less than 10, it's going to do everything that's inside these curly brackets. And the third part of this is something that I want to have happen automatically at the end of all of these statements. And what I'm going to do at the end of this is I'm going to say I equals I plus 1. So for I equals 0, I less than 10, I equals I plus 1. So before anything happens, this is going to set I to 0. And then it's going to ask, is I less than 10? And it is, because it's equal to 0. So it's going to do everything that I put inside these curly brackets. And then at the end of that, it's going to do this, which says set I equal to I plus 1. That's going to make I equal to 1. And now it's going to ask this question again. It only does I equals 0 once in the very beginning. So now it's going to ask the question, is I less than 10? Well, I is equal to 1. That's less than 10. It's going to do everything in here again. And then it's going to say I equals I plus 1. I is going to equal 2. Is I less than 10? Yes. It's going to do all of this stuff. Set I equal to 3. It's going to do this a total of 10 times. The last time will be when I equals 9. It will do all of this stuff and then set I equal to I plus 1. Now I is 10. Is I less than 10? No, because 10 is not less than 10. Now the loop is done, and it's just going to continue with whatever comes after the loop. This is a way to get a set of statements to run over and over again. And so I'm just going to tweak this code a little bit. So for I equals 0, I less than 10, I plus plus, print out, hello Nick. Sorry. I equals I plus 1. That's what I plus plus means, but let's be explicit. So what does this do? Prints out hello Nick 10 times. That's a basic for loop. If you got loops, you got conditionals, you got sequential statements, you've got what's called a Turing compatible computer. It's a computer that can basically do anything. If your language lets you do those three things, you can use that language to write a program that can do anything you can do in any other language that lets you do those three things, which is basically every language. So Java, Python, Basic, Fortran, COBOL, C, Algol, APL, whatever, machine language, right? As long as you got these three mechanisms. Loops are fun. What would happen if I said I equals I plus 2? It would do half as many times, because the first time I'll still be 0, and then I'll be 2, and then 4, and then 6, and then 8. And then the next time, 8 plus 2, I'll be 10, it'll leave my loop. So that'll only run a total of 5 times. What if I do plus 3?
3 times. 4.
4 times. Why 4 times?
0, 3.
It starts at 0, and then it's 3, and then it's 6, and then it's 9. And then the next time it's 12, which is too big. So it's kind of like 10 over 3, but rounded up. What if I do 300?
Okay.
Right? Why? Because I started off at 0, that was not bigger than 10, that was less than 10, so it did the for loop once. And then I got really big. What about that?
Infinite.
I was going to start at 0, it's going to execute the loop, it's going to set I equal to I plus 0, which is just going to leave it at 0. 0 is less than 10. That's an infinite loop. It's hard to tell it's doing anything except when it hiccups at the bottom. But it's spewing a lot of output. It's still hard to tell. Alright, so how do I stop this program? Hold down Control, hit C. So if I print out with a %i, the value of I after it says hello Nick, I put it back to I equals I plus 1. Alright, that's all that's going on. Here's another version of a loop. For I equals 10, I is bigger than or equal to 0, I equals I minus 1. Is that going to work?
Yes.
No reason it shouldn't. I should be 10. That's bigger than or equal to 0. It should say hello, and then set I to 9. And so on. So we can kind of do whatever we want with these for loops. And almost every language has a for loop of some type. And for loops are really useful when you want to do something a certain number of times. You know up front, I want to do this 10 times. Or you know up front, I want to do this however many times the variable x says. And we could do things like this. We could have an integer called number of loops, and we could say for I equals 0, I less than number of loops, I equals I plus 1. And since number of loops is 10, this will run for 10 times. What do you think this would do?
Let me get rid of that plus plus.
It's only worried about I, because you're not
Mm-hmm.
okay.
This is getting into some weird stuff now.
But it's nestled underneath that four.
Yeah.
So it prints 50 times.
Should print 50 times. So here's a way to think about this. This is the start of a for loop. Okay, it ends down there with that curly bracket. So everything between those two curly brackets is that outside for loop, right? Which is going to run, in this case, 10 times. Which means the stuff inside the for loop, which is these 3 lines, are going to get executed 10 times. So whatever this loop does is going to happen a total of 10 times. So what does this loop do? Well, it prints out hello Nick a total of 5 times. And it prints out the value of I next to it. That thing, that loop that prints out 5 times with the value of I, is going to happen 10 times. So there's a total of 50 of those if we were to count them. And this is the value of I that's being printed out, so you can see I was equal to 8 and it printed 5 times, and then I was equal to 9 and it printed 5 times. Okay, that's called a nested loop. And it's very much like if you've done this in algebra. I don't know if you've done this or not. Have you ever done summation symbols? So have you ever done a nested summation symbol? It's exactly the same thing. This is basically saying whatever's going on in here, do that as I goes from 0 to 10. Or 0 to 9, actually. And nested loops pop up all over the place in a lot of scientific calculations. If you deal with matrices, you'll always see nested loops. And again, I'm using indenting to help, when I read this, to help explain to me what is going with what. Right? Everything that's indented at this point is inside this inner loop. Everything that's indented to this level is inside this immediate for loop. And everything in my program that's indented at this level is at the top level. Right? It's not inside anything except the main program. And everything that starts in column 1 is outside of my main program. So the include statement and the declaration of main. And if I want to be explicit, I could print out the values of I and j inside here. And that either helps or makes it really confusing. But there's what's actually happening with I and j. All right. Yeah.
Will print do math? So if you said equals I equals percent I, and you labeled I as I plus j, will it do that?
Like that?
Yeah.
Absolutely.
Okay.
So anytime that we call any function, we haven't talked about functions yet, but printf is basically a function. The arguments that we're passing to it, if they're expressions, they get evaluated first. So this will actually take the value of I plus j at that point and pass that, and this would print out the sum equals, and it'll print out the value of I plus j. So we get that. All right, let's go ahead and take another break. and we will iterate further on this. Want a free book? I don't think I do.